Section 1.3 is on graphing scattergrams and linear relationships. So starting with part A right here, I'm graphing on a number line. In the first example, the number of homes sold by a real estate agent is listed in chronological order for 0, 3, 5, and 6. We just want to graph with the number line to begin with. To graph a number on a number line, you put a dot filled in over that number. So that would be 0, 1, 2, 3, 4, 5, and 6. If you'd like, you can label those so that we don't lose the fact that we've got all our numbers there. And you can see 7 and 8, so this is a correct graph. Okay, so those are the dots all graphed. Part B is going to ask us, did the agent's sales increase, decrease, or stay approximately the same? So you can tell they're increasing, right? Because the dots are all going up. We went from 0 to 3 to 5 to 6, so we're increasing. Slightly more interesting question in part C is, did the increases in the agent's sales increase, decrease, or stay approximately the same? So in this case, we're looking at how much it was increasing by. So the increases themselves decreased. Okay. Just a couple different things you can see on that number line. Okay, the next topic, to find the average or mean of a set of numbers. So what we need to do is add all the numbers up and then divide by the number of numbers that you added. So add all of the numbers up, or find the sum, and then divide by the total number of numbers. So in example 2, we're going to make a graph, and we're going to find the average and graph the average. So we're going to be graphing the number of water parks between 2000 and 2005. So there were 5, 11, 20, 21, and 25. Now this number line doesn't have scale, so I'm going to decide where I want to begin. I probably don't want to start 0 here because I got to go all the way to 25. It kind of cuts it off. So I'm going to start down at the end with actually just starting with my smallest number. So I'm going to start there with 5. Now, it's important that I don't put the rest of the numbers arbitrarily. I do need to keep a consistent scale. And it looks like I'm going to need a scale. I can't go by 5s. I want to scale by 1 because 20 and 21 are so close. We'll go 5, 6, 7, 8, 9, 10. The next one's going to be 11. 12, 13, 14, 15, 16, 17, 18, 19, 20. 21. 22, 23, 24, 25. Okay, and you can keep it going as far as you want, but it's important just to make sure that all of your dots are represented and that as far as possible, those tick marks are evenly spaced. All right, part B, I want to find the average of the data values. I want to graph it on the number line I created above. So I would start by adding up all the numbers, 5 plus 11 plus 20 plus 21 plus 25, and then I'm going to divide it by 1, 2, 3, 4, 5. There are 5 numbers I'm going to divide it by. So let me get our calculator. We are going to add all of those values. 5 plus 11 plus 20 plus 21 plus 25. That's 82. And I'm going to take 82 divided by 5. So I'm going to end up with 16.4. When I added them all up, it was 82 divided by 5 is 16.4. So finally, I want to graph my 16.4 on the number line. So let's count again. That's 11, 12, 13, 14, 15, 16. So 16.4 is right in between 16 and 17. And I'll label that as 16.4. I did the dot in red just to show that that one was the average, not one of the original numbers. Okay, let's look at, the back is the next section.